everyone, it's Zach, and today we're talking about Ohm's law, which is vital to understanding electronic circuits. So enjoy, and don't forget to like, subscribe, and click on the notification button for more electronics videos.
Ohm's law is a relationship between voltage, current, and resistance. Voltage is the difference in electric potential, current is the flow of electrons, and resistance is the ability to reduce the flow of electrons. However, let's understand these concepts practically through the following water tower diagram. Voltage can be explained as the height of water in the tank that creates pressure. The more water, the more voltage. The diameter of the pipe represents the resistance of the circuit. If there is a small hole, less water can escape as there is a greater resistance preventing it from leaving the tower. Then the flow of water leaving the tower represents a flow of electrons or current of the circuit. Now that we have briefly discussed what current, voltage, and resistance are, let's talk about the exact relationships between them as described by Ohm's law. Ohm's law states that voltage equals current times resistance, current equals voltage divided by resistance, and resistance equals voltage divided by current. This can seem like a lot to remember, but Ohm's law becomes simpler with the following diagram. In it, you see that voltage, current, and resistance form a triangle that quickly explains Ohm's law. By covering the V, you'll see that it equals IR. By covering the I, you'll see it equals V divided by R. And by covering the R, you see it equals V divided by I. Let's do a quick example. You have a DC circuit that has a voltage of 6 volts and a resistance of 3 ohms. Per Ohm's law, the current through the circuit is equal to voltage divided by resistance, or 6 volts divided by 3 ohms, which equals 2 amps. Now let's do an example where we solve for voltage using Ohm's law. You have a DC circuit that has a current of 1 amp and a resistance of 5 ohms. Per Ohm's law, the voltage through the circuit is equal to current times resistance, or 1 amp times 5 ohms, which equals 5 volts. To cover all aspects of Ohm's law, let's do an example where we solve for resistance. You have a DC circuit that has a voltage of 8 volts and a current of 2 amps. Per Ohm's law, the resistance through the circuit is equal to voltage divided by current, or 8 volts divided by 2 amps, which equals 4 amps. Now on to applying Ohm's law to alternating current or AC circuits. In AC circuits, the flow of electrons change directions back and forth. This flow of electrons causes the current and voltage to appear as a sine wave that has a magnitude as well as a direction in both the x and y planes. The directionality of the AC voltage and current are important to understand in order to apply Ohm's law to AC circuits. DC voltage, as shown in the graph below, only has direction in the x plane. Resistors also only affect voltage and current in the x plane. Therefore, the direction of the voltage and current will not be affected in DC circuits. AC voltage has direction in both the x and y planes. However, resistors in AC circuits only affect the AC voltage and current in the x direction. So what components provide resistance in the y direction for AC circuits? The answer to that is capacitors and inductors. A detailed description about the function of capacitors and inductors will be given in future videos. The important takeaway is that capacitors provide resistance in the negative y direction and inductors provide resistance in the positive y direction. A brief note about resistance in capacitors and inductors. Their resistance, which is called reactance, is dependent on the frequency of the input voltage and the capacitance or inductance of the component. Reactance is measured in ohms like resistance and functions the same way as resistance under Ohm's law. Therefore, for the remainder of this presentation, the reactance will be referred to as resistance to highlight how Ohm's law works. Now, how do you find the overall resistance of the AC circuit that will allow you to apply Ohm's law? The answer to that is through trigonometry. The overall magnitude or value can be found by the famous equation the square root of a squared plus b squared equals c, where the a value equals the resistor value, the b value equals the capacitor, inductor, or net capacitor-inductor resistance, and the c value is the overall resistance value of the AC circuit. Let's do a quick example. In the circuit, there is a resistance of 30 ohms in the x direction from the resistor and a resistance of 40 ohms in the positive y direction from the inductor. Note that J is a common way to denote the y-axis in electrical engineering. Now let's find the overall resistance of the circuit. The square root of 30 ohms plus 40 ohms is equal to 50 ohms, which is the overall resistance of this AC circuit. But resistance in AC circuits is also directional. So how do we find the directional component in the form of an angle? We do this by the following equation from trigonometry. The inverse tangent of the magnitude in the y direction divided by the magnitude in the x direction. In the example, the direction of the resistance is found by the inverse tangent of 40 divided by 30, which equals positive 53 degrees. Before applying Ohm's law to the above circuit, let's briefly talk about the resistance of the circuit if a capacitor with a resistance of 40 ohms was used instead. The magnitude of the resistance would not change because the squared value of the negative value is the same as the squared value of a positive value. However, the inverse tangent of negative 40 divided by 30 is equal to negative 53 degrees. Now on to applying Ohm's law. Let's add a voltage of 170 AC volts to the circuit. The current of the circuit is equal to the voltage divided by the resistance. In this case, the current equals 170 volts at 0 degrees divided by 50 ohms at positive 53 degrees. This gives us a value of 3.2 amps of current at negative 53 degrees. The negative 53 degrees tells us that the current lags the voltage by 53 degrees. What that means is that the current waveform starts 53 degrees after the voltage waveform. Let's understand this practically. AC voltage is given in terms of frequency, and for this circuit, it's at 60 hertz. The period, or the time it takes a voltage to complete one cycle, is 1 over the frequency, or in this example, 1 over 60 hertz, which is equal to 16.67 milliseconds. The current waveform will start 16.672 milliseconds, times 53 degrees divided by 360 degrees, which is equal to 2.45 milliseconds after the voltage waveform. But what about the circuit using the capacitor? Per Ohm's law, the current equals 170 volts at 0 degrees divided by 50 ohms at negative 53 degrees. This gives us a value of 3.2 amps of current at 53 degrees. The positive 53 degrees tells us that the current leads the voltage by 53 degrees. What that means is that the current waveform starts 53 degrees before the voltage waveform. If we use the example where the voltage has a frequency of 60 Hz, then the current waveform will start 2.45 milliseconds before the voltage waveform. Now let's find the voltage of the circuit using Ohm's law if we are given a current of 2 amps at positive 5 degrees. Per Ohm's law, voltage equals current times resistance. Therefore, the voltage of the circuit equals 2 amps at 5 degrees times 50 ohms at positive 53 degrees, which equals 100 volts at positive 58 degrees. As the voltage has a positive 58 degrees, it leads the current that only has an angle of positive 5 degrees. For practice, let's find the voltage of the circuit that uses a capacitor instead of an inductor. Per Ohm's law, the voltage in the circuit equals 2 amps at 5 degrees times 50 ohms at negative 53 degrees, which equals 100 volts at negative 48 degrees. As the voltage has an angle of negative 48 degrees, it lags the current by 53 degrees. Hey everyone, I hope you enjoyed this video on Ohm's law, and don't forget to like, subscribe, and click on the notification button for more electronics videos.